Similarity transformations. Drawing non-rigid transformations. Triangle GHI has vertices G at -4, 2, H at -3, -3, and N at -1, 1. Suppose the triangle is translated 4 units right and 2 units up, and then dilated by a scale factor of 2 with the center of dilation at the origin. Sketch the resulting image of the composition of transformations. A series of slides follows. Before looking ahead, try to design a strategy that will lead to a sketch of the composition described. Check to see if your strategy is the same as the strategy that follows. The first step is sketching out the 3 vertices and drawing the triangle. Alright, we have drawn the triangle. Now, let's locate the translation of this triangle, because we're going to be translating it 4 units right and 2 units up. So what are the coordinates of our new triangle vertices? Alright, so since we are going 4 units right, we add 4 to each of these first x coordinates here. So this G prime has -4 and that becomes 0, -3 and that becomes 1, -1 becomes 3 because we've added 4 to each of those. Now for the y coordinates, we're going 2 units up. So we're going to add 2 here and get 4. We're going to add -3 and 2 and get -1. And we're going to add 2 to 1 and get 3. So here are our new coordinates, which we've sketched out. So we've drawn our new translated triangle. Alright, now we're going to be dilating this triangle from the origin with a scale factor of 2. So what do we do with these coordinates to find our new coordinates? So because we're dilating from the origin, it's really easy. We just multiply each of these numbers by 2. So 0 remains 0, 4 becomes 8, 1 becomes 2, -1 becomes -2, 3 becomes 6, 3 becomes 6. So here are our new coordinates of our the vertices of our newly dilated triangle. So we map those out like that, and we connect the dots. Once we connect the dots with these purple lines, we have our new triangle, triangle G double prime, H double prime, I double prime. Drawing transformations. Triangle LMN has vertices L at 0, 2, so here's L, M at 2, 2, so M, and N at 0, 1, N. Sketch the resulting image of the composition of transformations. Alright, so here is our triangle. So the first thing we're going to do is reflect it across the x-axis. So that gives us this point reflects there, this point reflects there, this point reflects there. So this is our new triangle. Alright, then we are going to dilate by a factor of 2 from the origin. So all we do is take these coordinates and double them. So we have this point is at 0, -1, so that becomes 0, -2 there. Alright, this point starts out at 0, -2, so it becomes 0, -4, which is there. And this point is 2, -2, so that becomes 4, -4, which is here. So here is our final triangle. Here is our solution. What is the composition of transformations that maps trapezoid ABCD onto trapezoid MNHP? Write the mapping in a second way using XY notation. Alright, so we have our trapezoid here, and we want it to go over here. So how about the first thing we do is dilate it with a scale factor of 0.5. That will make it small. So to do that, we take our points. So this point right here is -2, 2, and we'll divide each of these numbers by 2. That would give us -1, 1. So this is our B prime here. Alright, this point is -6, 2, so that would become -3, 1. Okay, this point is -8 comma -2, so that becomes -4, -1. And this point is -1 comma -2, so that would become -1/2, -1. All right, so here's our new little trapezoid. Now we just have to reflect that across the y-axis, and that lines up perfectly. So that would be, first we did the dilation with a scale factor of 0.5, and then we did a reflection across the y-axis. So when we check out our answer, that's correct. We did this one. However, you could have also switched the order. We could have reflected the large trapezoid over here and then dilated it down in size. So yes, the composition is commutative. It does not matter which order we do these in. We will end up in the same place. And this is a way to write it out so that each of our points, when you're doing the dilation, that's how we did the math for that. Like, you just take each coordinate and you divide it by 2, or multiply it by 0.5, like that. That's how we did that quick dilation. Describe and write symbolically in 2 different ways a composition of transformations that maps triangle ABC onto FGH. Alright, so if we first reflect it across the y-axis, so we'll do a reflection across the y-axis. So that would put it like this. All right, C is 3 units. All right. So this is our triangle. Then we can dilate it. So using rays, so we would have like that, and like that. So what is this scale factor? This length here is 2, and this length here is 3. So that's a scale factor of 3/2. So that would be a dilation of 3/2 from the origin. So here we have reflected over the y-axis and then scaled by a factor of 1.5, which is 3/2. All right, so we wrote it like that. The dilation and then the reflection over the y-axis. You could also do it in the other way. That would have worked too. So you could first dilate and then reflect, or you can reflect and then dilate. And this is another way that you could write it in order to do the dilation quicker. Just you multiply the x and y by 1.5 and 1.5. Describe and write symbolically a composition of transformations that maps triangle ABC onto triangle FGH. Alright, so first let's rotate this blue triangle 90 degrees so that it is in the same orientation as the red triangle. So that would mean this is at 0, 4, so that'll be -4, 0. This is at -2, 4, so that'll be -4, -2. And then this point where C is going to be, right now it's at -4, -2, so that will be at 2, -4 down here. So then we'll connect the dots. All right, so we've now rotated it 90 degrees. So rotated 90 degrees, and now we'll do a dilation. So if we have our lines here, you can see that from the origin, we can dilate it down like that. So what is the scale factor? All right, well, let's take this side. This has a length of 1, and this side has a length of 2. So when you have 1/2, our scale factor is 0.5. So that we do a dilation with a scale factor of 0.5. And that will transform this triangle into this one. So we're going to rotate about the origin 90 degrees, then scale by a factor of 0.5. So this is how we wrote it out, the little composition to get triangle ABC onto triangle FGH. We could have also done it in the opposite order and that would have also worked.